Hi everyone. In this video, we're going to go over chapter 6, which is about the foundations of business intelligence and databases and information management. So what does a database mean? So it refers to a group of related tables, and the book calls tables here as files. So a table consists of related records, and a record in this case is a row in a table, and which basically um, has related fields, and the field is the column. And attribute and field basically mean the same thing. They are characteristics or attributes about that entity we are collecting data about. So an entity can be anything. It can be a person. It can be transaction. It can be anything that we want to collect the data about, right? So it has to be a certain theme. So it can be a patient, it can be visits, it can be anything that we have covered actually in the hands-on exercises that you have seen when you were working on Excel. So this is a kind of an illustration of a database, and you are already familiar with database since we have worked on SQL exercises at the beginning of the course. So we have here a database that consists of a couple of tables, related tables. And then every table is an entity, right? And every table has columns and rows. So the columns, they are considered fields, and the rows are considered tuples, or we call them also records, right? So one thing that I want you to keep in mind is the difference between bit and byte. So the bit represents either a 0 or 1, right? And a byte represents any letter or symbol or character that we have in a database. So for example, if I have the number 1 or a number 2, for example, in my Access or in Excel, that's considered a byte, right? A letter A is considered 1 byte, right? Any character symbol in Excel is considered a byte, right? So exclamation mark, that's 1 character, that's 1 byte, right? In terms of data size. So there has been problems with traditional file environment or table environment. So different departments might have different tables that they collect data for. For example, we have the sales department is collecting data about customers, right, separately. And then the accounting department collects data from about the customers separately. And we have the production company collects data about the shipment, again, about the same customer. So now we have redundant data that is maintained in separate departments, right? And this redundancy, when we collect data about the same thing in different places, different locations, might lead to inconsistencies when we, in terms of spelling. For example, if I'm spelling the name of a person, I might make a mistake in misspelling, right? So that's related to inconsistency, right? So you might have noticed that sometimes you would receive the same advertisement in your mail from the same company, like Ross or let's say Kohl's. They send me the same advertising twice because they misspelled my name in one, and the other one they got my name correct. So that's what we mean here by inconsistency. And then program data dependency. So this is sometimes one program uses zip code as only 5 digits. Other program uses zip code as 9 digits. So in this case, when you are creating a report using those 2 separate systems, it takes almost 2 weeks actually, because you need to clean and reconcile those disparate different formats for data, so that way you can create a coherent report, right, that reflects both programs. So then a database here is a solution for that traditional file environment, right? A database which is one source of truth, that actually used by all functional areas. This is where ERP, that when we talked about enterprise resource planning, we say it uses only one source of truth, one database, and it is shared. Everybody uses the same data set, right? The same database. So then the data, it helps with centralization of data and controlling redundant data. So we don't need to collect the same data over and over from in different departments. So we have it only in one place, and we can pull it up in different uh, functional areas. So database management systems such as Microsoft Access is a database management system. SQL Server is MySQL, Oracle, DB2. Those are examples of database management systems, and they help actually interface, or they interconnect between applications and physical data files, and they separate the logical and the physical views of data. So the logical view of the data is basically the ARD diagram that we have been working on, right? And the physical data is the actual tables that is populated, right? This is just the difference between those two. And the database management system helps solve problems that traditional file environment used to have, such as redundancy. We say that you might collect the data in different places, different departments, and eliminates inconsistency. So some departments might, or some systems within the same company might use X large as spelled out X large. Other databases or might use it as XL, right, as abbreviation. So now that is inconsistency. So it uncouples programs and data. Again, this is the example where we mentioned the zip code. Some systems might use zip code as 5 digits, others use zip code as 8 digits. We need to reconcile and make it only one, so we can have comprehensive database. And also database management systems enables organizations to centrally manage data and data security. So in other words, if I want to create a report, all it takes is a SQL command that you have been creating, right? And that in the traditional filing system, it took weeks, 2 weeks at least, to reconcile and come up with that report. That right now you can type a SQL command and to create that report. So as simple as that, actually, database helps and enables us to be efficient and timely. So again, this is a database here, as you can see, and database management systems gives access to different people based on their needs. So, but we have the same data source of truth, we can say. And then we have relational database management systems. Relational database management systems was introduced in the 70s by a person called Codd. So Codd, he's a pioneer who introduced the relational database, which represents 2-dimension tables. And he introduced also the normalization that we will talk about later. So then, so in the relational database each table contains data or entity and attributes. And again, there are some terms that you have been using, but we need to know what they are. So in terms of rows or tuples, those are the records on the rows in a table. And the fields, they are the columns. And they are basically attributes or characteristics about that entity. For example, the date of birth, that's a characteristic of the patient table or patient entity. First name, last name, address, and so on. Those are characteristics or attributes about that particular entity, which is patient, for example. And then we have key field. Key field meaning that field is uniquely identified. It uniquely identifies each record, right? And an example for a student table, for example, if here in the university, we can use a couple of key fields that can work as primary key, right? We can use student ID, we can use student email, because emails are unique, at least for the student's body. And then we can use Social Security. Those are candidates, we can call them key field, but we need to use only one primary key. In this case, it can be the student ID. And a foreign key, as we discussed actually in the first week of classes, and I mentioned that you can think about a foreign key as us citizens. So I am from the United States and I am considered a primary key in the United States. If I go to Mexico, which is a foreign country, and I'm included in Mexico, then I'm going to be considered a foreigner, right? So the same thing for a database. If I have a primary key for patient, like patient ID, which is a primary key for the patient entity or table, if I use it in the visit, so I include the patient ID in the visit table, then it becomes a foreign key. So this is the same, another example. We have the supplier table. It has a supplier number. That's the primary key. When I include it in the part table, then it becomes a foreign key. So operations of relational database management systems, we have been using the select, the join, and project is basically another example of select, and we have used that. And capabilities of database management systems, we have data definition. So this is where you can use database management systems to create tables and define primary key, foreign key. And we have data dictionary. Data dictionary in database is considered to be data about data. So for example, in a table for patient, we have patient number, right, or patient ID. So that's a data or field data, and we need data about that patient ID. So in other words, what is the size of that patient ID? What is the type of that data, or which is patient ID? And so this is an example of a data dictionary. We need to know the data type for that particular field or data. And then we need to have description about it. We need to have the field size. We need to know whether it is required. So in other words, we have data about data. That's what we mean by a data dictionary. And it is provided to us in database management systems. And then querying and reporting is also enabled by database management systems. And we have been using the data manipulation language, which is structured query language, SQL, right? And we have been using the select statement for structured query language in SQL. So other database management systems such as Microsoft Access enables reporting using the report function or capability. And this is an example of a SQL query. And so I want to ask you what would be the type of this join here, because we are collecting data from multiple tables. So from supplier and from part table, right? Is this an explicit joint statement or select statement, or it is an implicit join? So I want you to think about it. So explicit means that inner join, I need to see it. Implicit meaning that it joins those tables, but it is not explicitly listed here, right? So you can figure out and tell me what you think. So this is the query by example that we have been doing and we have done. So designing databases, we have conceptual design, physical design. Actually, we have conceptual design, logical design, and physical design. So the conceptual design is when you start scratching or writing the names of the tables and then how they are related to each other. And in other words, what is the data that you want to collect? I usually, when I design a database, I first look at the reports. What is the data that I need? I interview end users, I interview managers. What is the data that they need from that database, right? I look at the reports and maybe billing statements, what data that they need. And then that's how I start designing a database. And then you start with the conceptual design, just dividing tables into themes. That's kind of the best way to do it, which kind of helps in the normalization process. And then you have the logical model, which is basically the normalization process. And then the physical design, that's when you actually build the tables themselves as in the disk, in the disk drive. So normalization, again, I mentioned that it was introduced by Todd in the 70s. And if you know a business administrator, you can just call them in COD we trust. And this is kind of an inside joke for business administrators. So they know that COD is the guy who introduced normalization, which helps actually minimize redundancy and any anomalies and inefficiencies in the traditional system, traditional filing system. So we have referential integrity. That's part of the designing of database. What we mean here by referential integrity is that you will not be able. So let me show you here. In this example. So referential integrity, meaning that these tables are related because they have foreign key, they are related through the foreign key. So if I have a new entry and then I try to include a supplier number that does not exist here, the system will not allow me. So this is what I call it referential integrity. So it will not allow me to include a made-up supplier number that does not exist here. It has to be looked up and it has to exist here before I can include it here in the part table. So that's what we mean by referential integrity, meaning that I can't insert or make errors. It prevents me from making mistakes, right? And then integer relationship diagram. This is what we have been using when you were creating your SQL statement, right? I would always tell you when you have a query, you read the query, what the question is asking, and then you look at the ERD diagram or the schema to decide which tables you need to from or to select data from in order to decide where you are going to collect that data from, which tables, right? So that's, we call it entity relationship diagram, which is a diagram telling us this is an example of an entity relationship diagram. Yeah, those are the names of the tables, but they have fields, for example, your supplier ID, and so on. And it has also the logic relations between them. What is the relationship? Is it one to many, one to many to one, or many to many, and so on, right? So that's what we mean here by entity relationship diagram. We use it for to understand, and so we can retrieve data using the SQL statement. So it is very important that we have a correct data model in order to be able to serve our business efficiently. So this is an example of a table, order table before it is normalized. So we list all the fields that are possible that we want, or the attributes that we want to collect data about. And again, in one example or one essential step in normalization is to divide or to create tables based on themes, right? Because here I would have a lot of redundancies. For example, if I include supplier city, I have multiple cities, I have multiple states, multiple zip codes. I mean, I can repeat that redundantly. I don't need to waste actually space by redundantly collecting the same data over and over. So for normalization, it is, as I mentioned in one of the classes about database, that you can think about normalization as in the 6th grade when the English teacher told you every paragraph has to be about a theme. So in our case here in database, every table has to be about a certain theme. So now I want you to have a look here and see if you can identify any themes that can be its own table. For example, here we have order. This can be its own theme. And I have parts. This can be its own theme, right? And then supplier can be its own theme. So that's actually when we normalize the data, you can see that we have the parts, we have the supplier, and we have the order. Recreate this one. as a connector or as an associative entity, which is basically to breaks that many-to-many relationship, because none of the relational database management systems support many-to-many relationships between tables. So we need to break it down here. And that's why we have this order number coming from here and part number that is coming from here. So this is what we call it entity relationship diagram, and we need to be able to read these relationships, because I might give you examples, questions maybe in the quiz or in the exam about how to read this database entity relationship diagram correctly. So I would read it from left to right. So supplier. So I would read it. Every supplier, I will start with each or every. So every supplier provides one or many parts. So again, this is the crow's feet. The crow's feet represents the many sides, or it represents many, right? So every supplier provides many parts, and then every part is supplied by one and only one supplier. So you can read it this way. Another way, which is also correct, is to say every supplier provides at a maximum many parts, at a minimum one part, right? And then you can say each part is supplied by at a minimum one and at a maximum one supplier, right? So you can read the other ones as well. Here, for example, I can read it from part to line. I can say every part is ordered by one or many line item, and every line item contains one and only one part. That's how I would read it. Now I will read this one also. Every line item belongs to one and only one order, and every order includes one or many line item. So that's how I would read it, and this will be a good example for a quiz or an exam, how to read entity relationship diagrams. So as a result of large or big data that is coming from social media like Twitter, Facebook, and this big data is unstructured or semi-structured, and it has a variety of data types. Relational database is not able to handle such big data in an efficient way, because relational database, you have to normalize it and so on, right? So now no non-relational databases, which is, we call them NoSQL, were introduced, so it can handle such large volumes of unstructured and structured data, and it is easier to scale, more flexible, and stored across distributed machines. So cloud databases. So here, what we mean by cloud databases, they can be relational databases or non-relational databases, right? They are provided by cloud providers, and such as Microsoft SQL, Azure, or Amazon, or private clouds. And those databases, they appeal more to startups and smaller businesses because of the on-demand services that we talked about last week. So on-demand cloud services, meaning that you as a consumer or a customer, you use the cloud, whether it is software as a service, infrastructure as a service, or platform as a service, based you pay per use. Whatever you consume, you pay for that. Whether you use a lot, you pay a lot. You use less, you pay less. So you also scalability is very important in cloud, and that's why it appeals to startups and small businesses, because you don't have to have that large investment upfront, because you might succeed, you might fail, and you don't want to overspend. So then also we have distributed databases. Those are stored in multiple physical locations, and Google Spanner is an example of it. Blockchain. So all of us, we hear about blockchain a lot. What it is basically, it refers to distributed databases. and they are distributed ledgers, like um, peer-to-peer distributed databases, and they are used to verify um, and authenticate transactions, right? Because they cannot be altered or changed. They are very secure because of the encryption. So it is mainly used, blockchain now is used in financial industry, in the supply chain and medical records. So and cloud compute or blockchain is the foundation for Bitcoin or cryptocurrency. And this is an example of a depiction of it. And then big data. So from its name, big data is characterized with three V's, right? So we have the volume, that is large volume. So petabytes, zettabytes of data is just kind of to name a few. So volume, the first V. The second V is variety. That means it has different types of data. It can be images, can be videos, it can be voice, it can be text, can be any kind of data, right? And then the third V is velocity, which is the speed, the need for speed processing of that data, right? So that's why we call it big data. And it is usually coming from data that is coming from web traffic, social media, sensors, and so on. So for business intelligence infrastructure, we need tools that can help us obtain that information from separate systems and from big data. And those tools include data warehousing, data mart, Hadoop, and memory computing analytical platforms. Let's have a look at each one of those. So a data warehouse, you can think about it as a database that you have been working on. It's just similar to a database that you have been working on, like the clinic database, but it integrates the data sets from different sources. So for example, you have a data source that is coming from your transactional database. Yeah, another data source comes from social media. Another data source comes from credit history companies, and just kind of to name a few. And those different sources, they need to be integrated into a data warehouse using what we call it ETL, extract, transform, and load into a data warehouse. And then this data warehouse prepares that data, integrates this data, makes it ready for analysis and for reporting. Data mart is similar to a data warehouse. It integrates data from different sources and makes it ready for analysis and reporting, but it is more specialized. It specializes on a certain functional area like sales or production or human resource, just one functional area, one specialty. And then we have Hadoop. Hadoop, you can think about it as an open source big data software, right? So open source, meaning that it is free, it's not proprietary, right? So Hadoop is an open source big data software. And what makes it unique is that it enables distributed parallel processing of big data across inexpensive computers. So you can think about it. Actually, Bing search engine, Google search engine uses Hadoop technology in order to process any searches that we do. So when you type, for example, you're searching for UTRGV. So Hadoop or Google uses Hadoop, which actually uses parallel processing. It uses thousands of computers to process your search, to search for University of Texas Rio Grande Valley in multiple websites, and brings that output to you within milliseconds, because it employs and uses multiple computers to do that process. That's what we call it, distributed parallel processing. So key services of Hadoop is the data storage, the MapReduce, which again, that's what breaks data into clusters for work. and NoSQL database. So in memory, so again, when you talk about Hadoop, it is big data. Big data means not non-relational database, NoSQL, right? Big data doesn't support it doesn't have much to doesn't have to do with relational database. It is NoSQL. And then we have in-memory computing. So now, last week we talked about the ability of doubling the computing processing every 16 months, right? We talked about that. So again, in-memory computing requires optimized hardware, which has been actually there. It's already here, actually optimized hardware, which we talked about, the dual processor or multi-level, multi-core processors. And we talked about nanotechnology, so that optimizes the hardware, right? So as a result of this optimized hardware, now we can use in-memory computing or the RAM. And I give an example of RAM is like when you are cooking and you have your spices in the pantry. So you need to go to the pantry. It takes time a few steps to go to the pantry, open the door, and bring the spices that you're interested in while you are cooking. So now instead of going to the source of the spices, which is in the pantry, in our case here, instead of going to the hard disk to fetch that data that you need, now you can store it in the RAM or in memory, right? So that spices, you can put them on the top of the stove. So then while you are cooking, you just, take those spices and finish very quickly. So you don't have to go to the source of it and bring it. They are already ready for you in front of you. So that's what we mean here, the analogy of RAM and in-memory computing. So analytical platforms here, they are high-speed platforms that process relational as well as non-relational database, including examples of that is SAP HANA and Teradata. That's another example. And then we have Oracle and Microsoft SQL Server. They are analytical platforms. So this is a depiction of how a data warehouse works. Again, we say the data warehouse collects data or integrates data from different locations. So as you can see here, we have different sources of data, and data warehouse collects that data, prepares it for analysis, and then now we can run queries, reports, dashboards. We can run, do data mining from that data warehouse and do a lot of things with it. So analytical tools that will help for consolidating, analyzing, and providing access to vast amounts of data to help users make better business decisions includes multidimensional data analysis, OLAP, data mining, text mining, web mining. Let's look at each one of them. What we mean here by OLAP is online analytical processing. So online analytical processing, OLAP. So keep this term in mind, because I'm going to ask question either in the exam or in the quiz about it, right? So the essence of OLAP is the multi-dimensional or the dimensions, right? It is easily used in a data warehouse or in a data mart where you are focusing on the different dimensions. So different dimensions in that particular data warehouse includes pricing, cost, region, time period, and so on, right? Here is an example of dimensions. So for example, how many washers sold in the East region in June? So now we have the East region and the June as dimension for the washers sold, right? And this is what we call it a data cube, right? So we have one dimension for region, one dimension for product, one dimension for actual cost and projected cost, or actual sales versus projected sales. So those are different dimensions, and that's are used in the OLAP, right? And then we have data mining. So data mining, you can think about it as machine learning, right? Machine learning, we have supervised learning and supervised learning. And in the supervised learning is when we know already ahead of time what we are looking for. What is our target variable? Is it, for example, whether let's say that you are trying to classify, and that's part of the classification here, classify your customers as profitable customers versus unprofitable or not profitable customers. So you classify, you already know from historical data who were profitable, who are not, based on their characteristics, right? So you already know that ahead of time, your target variable. And unsupervised learning is when you don't know what you are looking for, right? You want the machine learning to do that analysis and figure it out for you. So examples of unsupervised learning includes associations, sequences, and clustering. Examples of supervised learning, machine learning, includes classification and forecasting. So for associations here, an example of it is when you buy a product from Amazon, you will notice that Amazon will tell you people who bought this product also bought this product, right? So that's what we mean by association. So the book also gives an example of association, saying that if a consumer or a customer buys corn chips, they are 89% likely, or 89% of the time more likely to buy Coca-Cola, right? So that's an association. You're associating the sale of corn chips with the sales of Coca-Cola, right? And we call it also market basket analysis, that association rules. And then we have sequences. Sequences, this is, it is like association. You're associating the sale of something with something, but with a dimension of time. So something preceded the other thing. So for example, here, the sequences example is people who buy new houses, within 2 weeks of buying that new houses, 85% of the time they are going to buy a security software like Ring, right? Or 85% of the time, people who buy a house, within 2 weeks after buying a house, they are going to buy a washer and dryer. So that's the sequence, right? Something happens, first buying the house, and then within 2 weeks, they buy washer and dryer, or they buy Ring security software. And then a classification is that when you have a variable that you want to predict or classify, and it is binary or categorical. So for example, you have customers in your company and you want to identify, classify them if they are profitable or not profitable, right? So in this case, you are classifying your customers based on, and you do that based on characteristics. For example, their age, their zip code, whether they own a house or not, depending on what company you are in, right? There are, we call those features or predictors in order to predict that and to classify, to help us with the classification. And then clustering is, this is when you divide, your data set into groups based on certain characteristics. And then we have forecasting. Forecasting, this is when your target variable is numeric, it's continuous, right? You want to predict customers who are going to spend, you want to predict the amount of money they are going to spend, for example, during holidays or during Christmas or during Black Friday, right? So you are predicting, forecasting numeric target variable. And then we have text mining. So text mining, you can, those text can be either doctor's notes, or it can be Amazon reviews, or it can be Twitter tweets, or it can be Facebook posts, right? And then you can mine this text. One of the analysis you can do for text mining is sentiment analysis, to see if it is, the sentiment was positive or negative. And then and then you go from there. So for example, I give an example of one of my students in the Master of Science in Business Analytics. He wanted to hire a consultant to do a sentiment analysis for his business. And he said he might have paid $100,000 for this consulting company to do that analysis for him. When he took our program, he actually was able in one of the classes to do that analysis, sentiment analysis by himself. And he saved himself $100,000 just because of taking our degree, which costs around $15,000. So that's just an example of text mining, and we're going to do text mining towards the end of this class, one of the hands-on exercises or projects that we're going to do in this class. And then we have web mining, so we can scrape data from the web. And another example here is the web usage mining. So I give an example. This is the trends.google. So some of you might have used it, but if you haven't used it, you can try to use it. So I like to watch UFC. And I want to compare some of the recent games between Islam Makhachev and Lex Volk. So, and you can see here through time, and this basically mines the web searches for those people, and it tells you what is how many times, or it just tells you the popularity of the search about those people and which states. And you can even do more than that, but you got the idea. Databases and the web. So a lot of companies utilize the web, and they provide access to their inventory on the web. So for example, I mentioned an example yesterday. I wanted to buy my 3-year-old a boxing set toy for him. So I was looking online, and I saw a couple of stores have it, but mostly online. And then I was able to see which stores have it in stock in store, so I can go and pick it up. And I was able to find it, for example, in Target, and they told me how many items they have, and they even gave me information about the aisle where I can find it. And that's just one example. And that happened to me the other day when I went to Home Depot. I was looking for a certain product, and they gave me the inventory, how many they have, and which aisle I can find it. So this is very helpful for companies when you link your database into the web. But again, make sure that there is security precautions about it. And another thing that I wanted to emphasize in this slide is the application server. Here it is a middleware. So let's look at this example. You have the web browser. The web browser still reads, and the web server, all of this here. So here you type English, right, into the web browser. The web browser transforms this through the internet. It transforms your English writing into HTML, right? HTML is the language that the web server understands. And the database server understands the language of SQL, structured query language, right? The SQL. So this is SQL language. This is HTML language. How can we make them talk to each other? We need a middleware. So we call this middleware, which is the application server, helps translate HTML into SQL. And the same thing also translates SQL into HTML, right? And that's one thing that I wanted to emphasize. So data governance is very important. So what we mean by data governance, it refers to the policies, procedures that are established or in order to establish rules for sharing, disseminating, acquiring, standardizing, classifying, and inventory information. So in other words, we want to have policies and procedures for who has access to what, who can make modifications, who can just see this information, who can share that information, and so on, right? And then we have data quality assurance. Again, 25% of critical data in Fortune 1000 companies databases are inaccurate or incomplete. So imagine 25% of data is inaccurate or are inaccurate or incomplete. So this is a big problem, and we need to solve it. And in order to solve it, you need to focus on the data quality audits and data cleansing, and because those 25% of critical data uh, that is inaccurate, incomplete, affects people's lives as well. It's not only making businesses lose business because of those mistakes, but also think about it from a consumer perspective. It affects their lives. If, for example, the credit history companies, they have inaccurate information about you, you will not be able to buy a car as a loan, or have a loan to buy a car, or you will not be able to buy a house because nobody will lend you the amount for housing. And you might also not find a job because if they have wrong information about you, that you have a conviction, or your or your the credit history is bad. So again, I just wanted to emphasize that we need to be careful. In companies, they need to have that data quality assurance in mind. So before, when we, I want you also to have a look at this case study. I want you to read this case study and watch the video and try to answer those questions, because some of those questions might be in the exam or in the quiz. So just make sure that you watch the video and read this case. It's very brief, and that's all that I wanted to cover today. And so thank you, and I will see you